2025. I am Dewi Wulandari, will be the Master of Ceremonies and moderator for our distinguished event today. Ladies and gentlemen, let me explain how this event will run. Firstly, we will have the national anthems for both Indonesia, Indonesia Raya, and Sri Lanka, Sri Lanka Mata. Next, we will have the speeches from Dr. Supandi and Professor Nilmini Lianage, and we will continue to the plenary session. Ladies and gentlemen, without further ado, I kindly request anyone please remain silent, attention, and respectful as we play the national anthems Indonesia Raya and Sri Lanka Mata. Okay, thank you very much, Miss Vivi and Mr. Eka, for playing the beautiful national anthems. Now, all the attendees, let's heed the speech from the Dean of Mathematics, Science, and Informatics Education Faculty. Please welcome Dr. Supandi. Dr. Supandi, it's at your convenience.
Thank you, Ms. Jayewardenepura. Uh, distinguished guests, honorable speakers, and esteemed academic from both national and international from Indonesia and Sri Lanka. Prof. Nilmini Livenage, Dean of the Faculty of Technology, University of the Jayewardenepura, and then Dr. Jayakodi, Head of Department of Science for Technology, and today's keynote speaker. In Indonesia, sometimes we call Ibu Nilmini Lianeje or and Ibu Gaya Jayakodi. uh, it, it means Ibu, it means that's mom. uh, Miss Agnita Siska Pramasdewi from UPGRIS Semarang and Miss Iza Larsati from University PGRI Semarang, respected college researchers and students, and then ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
First and foremost, let us offer our heartfelt gratitude to God Almighty from His abundant blessing and guidance, which have allowed us to come together today from the International Joint Lecture Series on Mathematics and Mathematics Education 2025. It is a great honor and conference. This event in a spirit of shared enthusiasm and academic collaboration with the University of Sri Lanka, University of Sri Jayewardenepura, Sri Lanka, and University PGRI Semarang. On behalf of the organized committee, I am pleased to extend a warm and silent welcome to all speakers and participation. I would especially like to express our deepest appreciation to our international colleagues who have graciously devoted their time to contribute their insight and expertise in these fields on mathematics and mathematics education. This lecture series serves as an important platform to strengthen global academic ties, broaden scientific perspectives, and foster international collaboration in advancing research and innovation in mathematics education. We are confident that this forum will spark fresh fresh idea and meaningful dialogue that will contribute significant to academic and social progress. I hope this meeting have a lot of idea to contribute from this academic and also at that time. It is also our hope that this event will not only promote the exchange of the knowledge, but also lay the groundwork for long-term partnership between institutions, University of Jayewardenepura, Sri Lanka, and University PGRI Semarang, and inspire a new generation of scholars and educators committed to excellence in mathematics and education. Ladies and gentlemen, in closing, I would like to extend our heartfelt debt to everyone who has support and contribute to the successful organization in this event. May this lecture series proceed smoothly and provide valuable benefit for us all. We wish you inspiring and engaging experience with warm research and sensory appreciation. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Supandi, our beloved Dean, for the very delightful speech. Okay, next, let's hear the speech from the Dean, Faculty of Technology, University of Jayewardenepura, Sri Lanka. Please welcome Professor Nilmini Lianage. Please, ma'am, time's yours.
Thank you. Good morning, everyone. All the distinguished invitees from Indonesia and resource persons from both countries, including my dear friend Dr. Gaya Jayakodi, and all the participants. It is with great pleasure that I extend my appreciation for the initiation of this valuable collaboration between our university in Sri Lanka and our esteemed colleagues in Indonesia. This joint effort makes a meaningful step forward in advancing our shared commitment to the development of mathematics and also mathematics education in both countries. I am pleased to note that the memorandum of agreement, it's already signed 2 days ago, and it is truly encouraging to see the project already taking shape through this lecture series. I sincerely hope that this initiative will serve as a strong foundation for deeper academic engagement, leading to future collaborations in research and other scholarly activities. Thank you, and I wish all the participants a fruitful and enriching experience. Thank you again.
Thank you very much, Professor Nilmini, for the very insightful speech. So, ladies and gentlemen, before we go to the plenary session, please, everyone, we will take the picture together. So, please, I ask Miss Vivi and Mr. Eka to help us. Help us to take the picture together. So I will count for the first slide. Please post your best smile, everyone. Maybe everyone, you can turn on your camera. So, Miss Vivi, is everything ready? Okay. First slide. 1, 2, 3. Okay, second slide. 1, 2, 3. Okay, Miss Vivi, it is enough? Is it enough? Okay. All right, thank you, everyone. Thank you so much. So, ladies and gentlemen, now we come to the main session, the plenary session for our event today. We will have 3 sections in this session. First section is a presentation from Dr. Gaya Jakodi, and then second section presentation will be delivered by Assistant Professor Agnita Siska Pramasdiasari and will be closed by last section by our first speaker, Ms. Iza Larasati. So, without any hesitation, ladies and gentlemen, please welcome our first speaker, Dr. Gaya Jayakodi's presentation. With them, mathematics knowledge for teaching. But before she starts, let me tell you her brief bio. So, Dr. Gaya Jayakodi is currently a senior lecturer and the head of the Science for Technology Department at the Faculty of Technology, University of Jayewardenepura, Sri Lanka. And then she is a dedicated and pioneering figure in mathematics education, holding a PhD from Simon Fraser University, Canada, under the supervision of renowned scholar Professor Rina Zaskis. And then during her time at Simon Fraser University, Dr. Jayakodi has recognized for her academic excellence and research contributions. She was awarded the prestigious President's PhD scholarship in 2013, and from 2012 to 2015, she received the Graduate Fellowship PhD. In 2014, her outstanding research efforts earned her Graduate Student Research Award. Dr. Jayakodi is also a life member of the Sri Lanka Association for the Advancement of Science, or SLAAS. She has held key leadership roles within the organization, including chair of the Committee for Popularization of Science in 2023 and the president of Section E1 for 2025, highlighting her commitment to the broader science community in Sri Lanka. Okay, I think that's the brief bio of the Dr. Jayakodi. So, Dr. Jayakodi, please, time's yours.
Thank you very much, Ms. Devi.
Yes,
good morning, everyone.
Ms. Devi. Good morning, ma'am.
I sincerely appreciate your warm introduction. And it's a great pleasure and actually an honor to be here and to be able to talk to a diverse audience from two countries who's passionate about mathematics and mathematics education. And before I begin, I want to give a special thank to Professor Agnita for initiating this wonderful collaboration between our University of Jayewardenepura and her university in Indonesia, enabling us to share our knowledge and research on mathematics and mathematics education. So let me share my screen. Hope you can see my screen.
Not yet, ma'am. I think it's still processing. Oh, yeah, now it's visible.
Okay. So give me a moment. Right. So what I'm going to be talking to you about today is based on a research that was conducted by my first MPhil student, Mrs. Rovini Ratnayaka, and myself. And Mrs. Rovini Ratnayaka is currently pursuing her PhD in Australia. And I want to acknowledge her tremendous work in this research. So this research explored the mathematical knowledge for teaching, in teaching the concepts of limit and derivative. So before we begin, let us understand what mathematical knowledge for teaching, abbreviated as MKT, means. In very simple terms, MKT refers to the knowledge of mathematics that is needed by a teacher to carry out the task of teaching math. Now let's look at an example to better understand this knowledge for teaching. Consider this example, a simple subtraction of two three-digit numbers. Now, this could be a little problem that could be given to a, say, grade 4 classroom. Now, all of us here know the answer to this. We all know how to work this out. But in a, say, grade 4 classroom, it's natural that students would come up with different answers to this. And again, we all, I'm sure, can spot the right answer, and we are all able to say that the student B and C answers are wrong. Now, but what a teacher has to do beyond identifying that this answer is correct and these answers are wrong, is that he or she needs to be able to analyze look at these solution paths of students and see where they have gone wrong, what mistakes they have done, what do their working tell us about their understanding of subtraction. Now, while I speak about it, I invite you to look at the two wrong solutions and see whether you can see where they have gone wrong. So a teacher has to analyze this and see whether is it because they have not understood subtraction? Have they not understood the way of writing? Is it something to do with maybe place value? Or is it a lack of understanding in maybe borrowing, regrouping, and so on? So this kind of knowledge, knowing how to work out a mathematical problem, as well as in this example, the ability to analyze students' answers and to see where they are lacking in their understanding, all is part of what MKT is. Now, let's quickly look at the evolution of this teacher knowledge. I'm sure you all might be aware that, the term pedagogy, prior to the 20th century, the term pedagogy only meant general pedagogy, and it had nothing to do with the subject content that the teachers were teaching. It was in 1986, it was Schulman who pointed out that there is an element in pedagogy that is subject specific. There is part of pedagogy that need the content. How you teach a subject depends on the subject as well. So he is the one who coined the term pedagogical content knowledge by bringing in the content into pedagogy, which is abbreviated as PCK. And ever since, researchers have been interested in exploring the special knowledge that is specific to teaching, specific to teachers. And they have come up with various models to try and understand this type of knowledge. And what we have adopted in our study is Deborah Ball's a famous theoretical framework by the name Mathematical Knowledge for Teaching in 2008. So let's have a quick look at her framework. This model is called a practice-based one because it was developed by now Schulman's, what Schulman pointed out was based on logical assumptions. Deborah Ball and her colleagues developed this theory based on classroom observations. They conducted a longitudinal study observing primary teachers' lessons throughout a full year, and they conceptualized mathematical knowledge for teaching as being consisting of two main domains: subject matter knowledge and pedagogical content knowledge. And these two domains were further broken down into subdomains, and they are given abbreviations. I will not go into each of these, but I will talk about what we have taken up in our study. So the subject matter knowledge, there are three subdomains under that. We were interested in what is called specialized content knowledge, abbreviated as SCK. In order to understand that, let me quickly touch on what common content knowledge is. As the name suggests, common content knowledge is the knowledge that we all have, common to all of us, common to a teacher who teaches mathematics, and also somebody else in a different profession who might need mathematics in it. Basically, the knowledge that we adults have about mathematics, the ability to work out a problem. But SCK, specialized content knowledge, is unique to the profession of teaching, and it is not typically needed by any other person in another profession or for any purpose other than teaching. So, for example, if you take a concept like, say, division, the common content knowledge would be that we all have is the ability to work out a division problem. But teachers need to possess something more than that. For example, they have to be able to explain the reasoning behind different division procedures, like the long division algorithm. And they have to be able to interpret division by using different models, for example, sharing model and measurement model, and so on. So their the type of knowledge that teachers need to have go beyond the common content knowledge. So what we were interested in was this SCK, the special knowledge that a teacher needs to have in order to teach. And we wanted to see what kind of SCK, what makes SCK in teaching of limit and derivative at secondary school. So our research questions were, we had two research questions. First was to investigate what specialized content knowledge is needed to teach concepts like limit and derivative. And secondly, having identified these components, what is the competency of our teachers in these knowledge categories? So now for this, we needed to operationalize SCK. How do we recognize this? So we again turned into literature. In order to help us with the analysis, we wanted some place to begin our work with. So the review of literature helped us to find several components of SCK, such as this. And we have used these components as a priori categories in our analysis. So the methodology, this was a purely qualitative study, and our participants were 15 in-service secondary teachers, 4 male and 11 female, in 11 government schools and private schools, and they were in 3 different districts. The kind of data we collected were, we observed the lessons of limit and derivative, we video recorded them, we took field notes during lessons, and we transcribed the video lessons for analysis. For the analysis we used constructs in the MKT framework, in particular SCK and the components we had identified in the literature. So here is a brief description about the 15 participants. They all had a bachelor's degree, general degree, with mathematics as a component, as a subject. Some of them had done an MSc in mathematics education. Some had postgraduate diploma in education. And there were teachers who had teaching experience ranging from as little as 2 years to 29 years. So for you to get an idea how our analysis looked like, it was both deductive and inductive. Deductive in that we were using those constructs in MKT, specifically in SCK, to identify our categories. We were looking at the data through the lens of SCK. And it was also inductive in that we were open to emergent categories from the data. So our knowledge about the rest of the categories in the MKT model, HCK, KCT, KSC, and so on, helped us to distinguish SCK from those, because sometimes there can be a little overlapping. So what we did was we went over the transcribed data a number of times, first familiarizing ourselves with the data and then highlighting and marking pieces of phrases where we thought that this was a certain piece of knowledge. And then in further rounds, later rounds, we could bunch them or group them together and recognize them as categories of SCK. So this is how our analysis looked like. So results, under the limit instruction, we could identify 4 components of SCK, out of which one was a new type of knowledge, new piece of knowledge that was not reported in the literature. The knowledge of building new knowledge on prior knowledge, connecting real-life examples, using multiple representations, a choice of good examples to make a mathematical point, and the correct use of mathematical language. Use of real-life connections was the new one we identified in this. And under derivative instruction, among previously identified categories, there was a new component, which is the use of, which is providing valid justification. The other three are again previously identified. So altogether, there were 6 components that we identified as belonging to SCK. And due to time restriction, I will only talk about the first 2 and the last 2. So let's look at the first one. Knowing how to connect previous knowledge appropriately to what is newly learned, we observed as a component of SCK in teaching both concepts, limit and derivative. For example, what you see here is a teacher bringing up or recalling the notation of a function, f of x, and explaining how it reads as the value of the function when the input is x. And he recalled how what students have previously learned is finding the value of a function for a particular value of x when x takes a value, say, a. But in contrast to that, what they are going to be learning now under limits was the limit of a function as x approaches to a. So they were highlighting the difference between what they have previously done and what they are doing when they are talking about the limit of a function. Now about their competency in this, not a lot of teachers were seen to be doing this. Even among the teachers who did bring in prior knowledge, could not properly connect it with the content that they were about to learn. So this is an area that needs work, but surely this kind of knowledge is part of specialized content knowledge. The second type, this is a new one. This is connecting real life examples or anecdotes or stories to the concept that they are going to learn, connecting real life experiences. Now, we observed this in the limit instruction, and teachers use 3 types of things related to real life little stories and analogies, and also personal experiences. This was done by many teachers. Out of the 15 teachers, 11 teachers did this when introducing the concept of limit. Let's see how they did this. We also, looking at the data closely, we could see that each of these teachers were using these real-life examples to explain different parts of the limit concept. One was to explain how x can approach a point A but not equal to A. For example, they took an example like, you have a rod and you keep breaking it. May say you keep halving it continuously, but the length of the rod never becomes 0. You will get smaller and smaller pieces. And to explain the word limit, excuse me, to explain the word limit, because it's a word that we use in our colloquial language all the time. So they took the colloquial usage of limit to say that it's the same idea that we see in the mathematical concept limit. For example, they were talking about the boundary wall, the limit of the school, to give the meaning of the word limit. And to explain how x can approach a particular point A from the 2 sides, they were taking as an example of a recording of a cricket ball flying in air. And for us to pinpoint a certain position of the ball, you can rewind and get to that point, or fast forward and get to that point. And to explain neighboring points to point A, they were taking examples like, you can get a sense of someone who you don't know, a stranger, by looking at the people around him, his friends. You look at his friends and get an idea of the stranger. So things like this they used to explain different parts of limit. Now, we justify that this kind of knowledge as SCK, since using real life examples can, and we can use that to reduce the abstract
Dr.
concepts
Jayakodi,
and make it
Dr. Jayakodi, I'm sorry for interrupting your presentation. We have 5 minutes more. We have 5 minutes more.
Okay, thank you.
Okay.
Yes, I think I will have to cut it short. So thank you for that reminder. So this kind of knowledge can be useful, especially in teaching concepts like limit, an abstract concept, to make it more concrete and accessible to students. But at the same time, we want to point out that the examples that these teachers were taking were not they were not adequate, and you might also see that they were not very appropriate. So they did not serve the purpose of giving the correct intuition of the limit concept. So I think I will talk about one more. This is providing mathematical justification. This was also a new component that we had identified. We observe this as an SCK in the derivative instruction. Now, when you derive the definition for derivative, there is a process with interconnected steps. You take you do certain steps, but sometimes teachers were seen not to explain why they were doing what they were doing. So that kind of knowledge is part of SCK. So we have identified it as part of SCK. For example, if you look at this, in this process, you take a point P on the curve, then you take a point. Now, these are actual words of the teacher. You take a second point Q on the curve close to P. It was not said why we take a second point, why it needs to be close. And you connect P and Q to draw the secant line. It was not said why we draw the secant line. Then he says we find delta Y. It was not mentioned why we do that. And we take the quotient. We make delta X smaller and smaller. None of these actions were justified. Whereas if you are to use that SCK, we will have to explain to students why you are doing each step, why you are picking another second point Q, why you are drawing the secant line, so you're approximating the tangent, and why it needs to be close so that the approximation is better, and so on. So let me wind up. Let me skip mathematical language, that other component I was planning to talk about. So if I skip to the discussion, this study contributes to our understanding of SCK by highlighting two new components, and especially these components came up in the teaching of concepts of limit and derivative in the context of advanced level in Sri Lanka. An MKT framework has previously been used mostly in primary school level. So this study extends the applicability of the framework to senior secondary teachers on more advanced concepts like limit and derivative. In terms of the competence of teachers, they were most good in choosing examples, but they were weak in giving mathematical justification. So in conclusion, I want to add that we have taken these findings of this research as discussion points in our teacher training programs, and we highlight their importance, especially in teaching advanced level students advanced concepts such as limit and derivative. So here are some of the references. And thank you very much.
All right, thank you very much, Dr. Jayakodi. What a oh my God, it's mind-blowing. Thank you so much, Dr. Jayakodi. Please stay. We will continue to the second speaker, and we want your appearance at the Q&A session after the third speaker presentation. Okay, thank you so much, Dr. Jayakodi. Okay, next we will continue to our second speaker, Associate Professor Agnita Siska Pramastiasari. But before she deliver her presentation, let me give a short introduction about her. So, Miss Agnita Siska Pramastiasari is an associate professor of Professor of Mathematics Education at Universitas Persatuan Guru Republik Indonesia, Semarang, Indonesia, and serves as the International Collaboration Coordinator at the Education Faculty. She holds a Master of Science from Curtin University, Australia, and from Universitas Negeri Surabaya, Indonesia. Her expertise includes STEM education, project-based learning, and integration of local wisdom in mathematics instruction. She has published over 100 academic works, international, LED international and national and international. Without further ado, let me welcome Ma'am Agnita to deliver her presentation. Please, ma'am.
Appreciate Ma'am Dewi. Thank you very much for moderating us. And I would like to greetings my great fellow, Dr. Gaya. Thank you for your sharing here. It's pretty interesting, and hopefully all the students and the participants here also can take many advantages. And please allow me to share another similar topic to Dr. Gaya. It's related to the mathematical knowledge for teaching as well, but I'm trying to bring like the connection between the university mathematics and school mathematics. Ma'am Dewi, can you see my PowerPoint right now?
Okay, it's visible now, ma'am.
Okay, thank you very much. Okay. Ladies and gentlemen, dear participant here, this is my honor to share with you and have an opportunity to discuss with Dr. Gaya, Miss Iza, and all the participants here. So today I would like to present one of my scientific paper entitled Connecting University Mathematics and School Mathematics to Address Clients' Double Discontinuity. I would like to take one of case in the ring theory. So this topic actually quite related to the topic that has been explained by Dr. Gaya before. If the before is related to the subject content knowledge related to the limit, so this is kind of one of advanced mathematical knowledge that also taken by the students in Indonesian teaching preparation program. So based on the background that in many of teacher preparation program in Indonesia, all the students have to take the advanced mathematical knowledge as a compulsory subject, such as abstract algebra. They have to take the real analysis, analysis complex, and many other advanced mathematical knowledge. So here, in this case, abstract algebra, in a teacher preparation program, particularly in UPGRIS, this is divided into two sections. That is group theory and then ring theory. On the one side, it can be seen that this kind of topic are valuable for deepening the students' mathematical understanding. So they can have the fundamental concept of mathematics for their future teaching. But then for the other opinion, we could find that students find difficulty in looking for the relevance for their future teaching. So how? Here, I'm trying to find what kind of experience by the students in the teaching preparation program by having this kind of such course like ring theory. So they may find it's difficult because they are struggling to see the relevance of abstract concept like inverse and identity elements from the ring theory or from group theory to the secondary levels topics such as exponents or inverse function. Some of the undergraduate students in the teacher preparation program might understand about the inverse itself, but then while they are studying about the inverse element in group theory or ring theory, they just do not see the relationship between the inverse that they have already learned from the senior high school. Okay, so this phenomenon we could see as a disconnection between the university and school mathematics. So this is like the undergraduate students who are in the teacher preparation program do not realize that when they are in the senior high school, they have already learned about the school mathematics such as the inverse, exponent, and then when they are in the university classroom, they also do not realize that many mathematical concepts they have to master that is support their mathematical concept for teaching in the secondary school. So the significant gap known as the Klein's double discontinuity. The first discontinuity is like when they are in the university level, they do not realize that all the thing has been learned in the school mathematics teaching. But then when they are back to their teaching in the secondary, they could not also how to use the university mathematics knowledge that they have already obtained to teaching their students. So this is like the mathematical knowledge for teaching that has been explored by Dr. Gaya, that this is pretty important for the teacher as well to explain the basic concept for their students, how to deliver in such a way so that the students can easily mastering the concept in mathematics. So my presentation here would like to explore how abstract algebra, particularly ring theory, can be meaningfully connected to school mathematics through concept-by-concept links. By identifying this direct connection, we aim to help my students here to have a better integrating their university knowledge into an effective teaching practice. So this is kind of effort to make to bridge the curriculum gap between the university and school mathematics, and also it would like to strengthen the mathematics teacher education. So the data collected from the pre-service mathematics teacher who just enroll in ring theory, they are in the one group, in the one classroom, divided into 6 groups. And during one semester, there are over 14 course sessions. Each group have to identify the key concept from the ring theory. They have to map the related secondary school mathematics topic from the official syllabus, whether this is the junior high school or the senior high school. So in Indonesian education system, for the senior high, we have like junior high school and senior high school as a secondary school here. So after they have already mapped the connection between the link of the topic in the school mathematics and the university mathematics, they are trying to construct concept by concept connection between 2 levels. And after we gather the data, we employ the data analyze based on miles. The first one is data condensation, and then display it, and then showing a conclusion. During the data condensation, we have an output from the 6 group, and then we were trying to reduce and categorize all the things from each group. And after that, in the data display, as a researcher, we are going to, we have a connection, we see the connection, and then organize into the table and examine descriptively based on Zaski's criteria. So she is one of wonderful researchers and also Gaya was
Yes.
Asia. Okay. And then during the we have already connection were categorized using Suminan framework, which is includes that as trying to mapping the alternative equivalent, how to two different level in school mathematics and then the university mathematics facing the equivalent representation, and then see the logical implication, the procedural links, hierarchical relationships, and the real world application. As we know, this is become a most important part. This is also explained by Gaia that the real world or the real life is becoming important to make an abstract idea become more concrete. And this is the categorization of the mathematical connection using the Suminan framework. So in the first category, we have an alternative representation. So this is kind of if we have one concept is represented in different ways, such as a symbolic in algebra, graphic in geometry, and pictorial in diagram, manipulative using the physical object, or verbal description by spoken and written expression. And then second category, this is the comparison to common features. By looking at the two concepts sharing the some feature in common, so we could easily identify whether this is the literally similar or differently different. Right? And then using the equivalent representation, generalization, this is like one concept is an example instance of another concept. So another is hierarchical relationship. This is one concept is component or another concept. So it's kind of two concepts should be mastered first until the next one. And the other category is logical implication, procedural, and real world.
Okay, I think Mom Agni now is out of the line. So please wait for a minute. Wait for her a minute.
Oh, sorry, Mom Dewi. I'm getting lost.
It's okay. It happens to everyone, Mom Agni.
Okay, thank you. I will continue my presentation. Do still have more time, Mom Dewi?
Yes, we have 7 minutes more,
Right,
Mom.
that's enough. Thank you. All right. As we discussed before, that the real world application is so much have an immense impact on how the students understand the abstract, become more concrete. So this is kind of the nature of the real the ring theory and group theory itself that has the abstract concept, how to make it more concrete for the students. So there are at least three what's that? The most finding it, the most important finding, that the most eye-catching, I mean, like, wow, that we could see from how the students
Andara.
find the
Right, right.
while they are trying to map the connection between two level in school and in the university. So the first one is we have looked at the students have the different representation of their approach. Each of group use the very format to make a link concept by concept connection, not in the table for sure, but they were trying to identify whether this kind of concept is related to the concept in school mathematics. But some of the groups also have the clearly matched specifically to identify the properties in group and ring theory to the school mathematics. They also include the brief explanation why is it, and indicating that they fully understand why is it connected, and other listed concept without any connection or explanation. That's okay. And then in the end, I'm trying to have the big picture of how the pre-service mathematics teacher could make a big picture and comparing to the framework that has been found by the previous researcher. And the second point is the common connection identified. So we found that most of them identify a certain concept link, that is the ring properties related to the number operation and in school mathematics. This is the fact that we know that the ring properties is closely related to the number operation. It is clearly and easily identified by them, but then we still have many other concepts that also could be connected to the concept. So this recurring connection appear group showing as a consensus. Okay, and the point is the limitation, as we know that most of them already focusing on the number operation. So any other do not noted that there are many theory that were not matched to school level topics. So some link were inaccurately mapped, not fulfilling the concept by concept as the criteria based on ZSKIs. And this is what happened that we called as a client's double discontinuity, a gap between university and school mathematics content. And this is the concept by concept connection. It's created based on the analysis of syllabi of ring theory and school mathematics in Indonesian context. So maybe it could be different from other country, but then we are trying to use the senior and junior high school curriculum in Indonesia for mathematics and connects to Suminen's category of mathematical knowledge. So this is the comparison connection that has been identified by the pre-service mathematics teacher. So the concept in ring theory, we have algebraic structures and properties that it also become the fundamental concept for secondary school mathematics concepts such as the function, domain, identity, inverse, number systems, and operators, solving linear equations. So some of the students in the teacher preparation program just realized that actually the fundamental concept of solving linear equation is coming from the ring theory and group theory. And also the binary operation. The commutative ring theory is also work in fraction, homomorphism in equality, function, and mapping. And then the ideal in number system subsets, inverse in multiplicative reciprocal, negative numbers. So inverses also have the different perception for the students at the first time, because they have to hit the different aspect with the binary operation itself, where they work at, like in addition or the multiplication. And this is the the comparison connection between the Suminan framework and the identified by the PMTs in UPGRIS. Then, so what the implication for educators? By knowing this kind of discontinuity as a teacher, educators, provider, so we have to prepare for designing the curricula and resources that fits the university and school mathematics level. And then how to make it more real while in the teaching process as an educator for teacher, prospective teacher, we are trying to make a concept by concept analysis to strengthen the PMT's understanding. So future studies need to explore how a pre-service mathematics teacher apply this connection in the classroom practice. So to sum up this paper, this presentation, the study shows that pre-service mathematics teacher mainly identify basic connection between ring theory and number operation, but then they have a limitation in broader links. It's because they have a limitation in teaching experience, and also because of the nature of the ring theory, it's quite abstract. And then it also because of the lack of opportunity to build connection during instruction. So as an educator, we could have open more opportunity to our students to have opportunity for them to make a connection, analyzing the connection between the topic in advanced mathematical knowledge in the university to make connection to the curriculum in school maths. Hopefully, these teaching resources can help them to bridge the university and school mathematics. So that's all my presentation. If you have any further question or any discussion, feel free, and I would like I will be more than happy. Thank you, Ma'am Dewi, for the opportunity.
All right, thank you so much, Ma'am
Thank you so much.
Hasnita. What a very interesting topic, bridging university and school mathematics, right? Oh, wow. Okay, thank you so much, Ma'am Hasnita. So, ladies and gentlemen, let's go to the the last section of this plenary session. We will have the last speaker, Miss Iza Larasati. Before Miss Iza Larasati present her presentation today, let me introduce her briefly. So Miss Iza Larasati is now an undergraduate student of Mathematics Education Department, Universitas Persatuan Guru Republik Indonesia, Semarang, Indonesia, year 2021. She is now involved in some activities such as Kampus Mengajar Batch 6. So Kampus Mengajar is such a community service activity in school for about 6 months. And then Iza is also experienced as the facilitator of physical, intellectual, emotional, and spiritual quotient for the fresher of Universitas Persatuan Guru Republik Indonesia Semarang, Indonesia. And she is now doing her research for her thesis with the ethnomathematics. That is also will be presented in this section. So please, Miss Iza Larasati, time's yours.
Thank you, Miss Dewi.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Respect Dr. Gaya Jayakodi, Head Department of Science of Technology, also the speaker today's session, and Associate Professor Agnita Siska Pramestiasari, the speaker today's session, and all participants. Introducing myself, I'm Izala Rasati, a student of PGRI University Semarang. Here I will present my research result on TILIP, enhancing elementary student numeracy skill through ethnomathematics-based learning and analysis minimum competency assessment result. For the introduction, foundational to academic successful and daily problem solving. In Indonesia, over 50% of elementary students score below minimum numeracy competency national assessment 2021. Weak numeracy hinders learning in higher grade and everyday decision making. Safari and Hassana 2023, Wahyuti et al. 2023. Students often see math as abstract and irrelevant, Angrini et al. 2024. 62% find math difficult and disconnected from real life, Brahmana et al. Teaching methods are often rote-based and non-contextual, Putra et al. 2024. PISA 2022, Indonesia ranked 68 from 79, Eric's math score 379, Heavy and Saleh 2020. Only 30% of Indonesian students saw adequate numeracy, AT and LEDE 2022. Limited teacher training linked to lower student outcomes, MUA 2021. Furthermore, numeracy beyond counting in analyzing data, interpreting information and solving real-life problems, Nurida 2023. Indicator numeracy, use of number or symbol in context, Winata et al. 2021, and data interpretation and decision-making, Nasoha et al. 2022. Integrates math with local culture and daily life. Make math learning more meaningful and engaging, Lestari et al. 2020. 4. Encourage critical thinking and preserve cultural identity. Most focus on cultural resilience or engagement, Ibrahim and Wahid. This study explored the effect of ethnomathematics on numeracy performed DMZA. For more methods, design quantitative quasi-experimental when group pretest post-test to access change in numeracy skill. Control group not used. Comparison mode within the same group. Pre and post. Location and sample. State Elementary School for Temuireng and 35 grade student via sample random sampling. Variable dependent ethnomathematic based learning. Dependent MCA score, real world math, data interpretation, logical reason. Procedure, coordination, test creation, intervention, and analysis. Data collection, pretest, post-test, observation, and documentation. Data analysis use SPSS, test include normality, homogeneity, parity test, and gain. Instrument, standard MCA question from the government, tier for validity. Next, result and discussion. Objective to evaluate the effectiveness of ethnomathematics-based learning in improving student numeracy skill at State Elementary School for Temuirang. Initial assessment pretest revealed low numeracy skill. Average MCA score was to 27.83, below the competency threshold. Intervention, ethnomathematics-based learning implement use local culture elements. Result, post-test show significant improvement in MCA score, indicating positive impact. Learning approach integrates traditional game, engklek, congklak, marble to make math learning engaging and culturally relevant. So, here is engklek game. Engklek is a game where game jump over a rectangular box drawn on the ground. It's closely related to geometry concept. Solid all 2000 and 2024, Afghani et al. 2024. The game not only makes learning enjoyable, but also introduces mathematical ideas such as shapes, size, and numbers. Observation during the activity show that students were able to identify and compare geometry shape used in the playing field. Circle for base, rectangle for boundaries, estimate distance, and count score using basic arithmetics. Thus, the activity support both conceptual learning and practical application, contributing to the overall improvement in MCA numeracy score. Furthermore, is congklak game. Congklak is a traditional game that's relies on strategies and counting skills. Soliha et al. 2022, Ayuningrum et al. 2024, Haryadi et al. 2024, Permatasari et al. 2023. This game is played by two pupils using a congklak board, which consists of 14 small holes and 2 large holes in the middle, called rumah-rumahan. Each player fills the small hole with seed, which can be seal, small stone, or grains. The congklak game can be utilized as a medium to introduce children to various counting concepts. But basic concept and other concepts such as addition, subtraction, and multiplication method, Matulesi et al. 2022. Furthermore, marbles game, the game of marbles, known as gundu, is of the most popular traditional game in Indonesia. The game involves small balls, usually made of glass, with a comb size of about half inch or 1.25 centimeter. The game of marble has a close relationship with ethnomathematics, which link mathematical concept with local culture. Octariana 2022, Sarah et al. 2022. The game involves drawing a circle on the ground of the playing area, which is a real example of the concept of flat geometry, and the marble themselves are spherical, providing an opportunity to teach the concept of physical figure and the properties of shape in geometry. Therefore, based on the above explanation, the traditional game of marble is very good and useful in learning mathematics. Sarah et al. 2022. Main findings for the first, interpretation of result. Significant improvement in numeracy, MCA, linked to cultural relevance of learning material, increase student engagement and motivation, opportunities for critical and creative thinking. For the second, for educational implication, ethnomathematics encourages contextual, meaningful learning, but math with student culture and identity, enhance participants' confidence and motivation, useful for curriculum design and education policy. For the third recommendation, scale up research across schools and regions, conducts longitudinal studies for long-term impact, include formal assessment of life skill and character development. The latter conclusion, the study found the ethnomathematics-based learning in significantly improved student numeracy skill at State Elementary School for Temuiran, as reflected in a substantial increase in minimum competency assessment or MCA score from an average pretest score of 27.83 to a post-test score of 56.17. This improvement supported by a statistically significant t-test result highlights the effectiveness of contextual, culturally integrated teaching beyond test score. The approach also enhance student engagement, problem solving, and motivation. The traditional game played a key role. The assessment remains an area for future research. The study recommends teacher training, community collaboration, and further research across diverse settings to maximize the benefit of ethnomathematics in mathematics education. Thank you for your attention.
Okay, thank you so much, Ms. Harasati. Oh, wow, it's so heartwarming for knowing our student, our beloved student, present her research. It's really heartwarming. Sorry for being emotionally. Okay.
Okay, ladies and gentlemen, we now come to the Q&A session. So please, maybe Miss Titi or Mr. Eka can pin all the speakers here. All right, ladies and gentlemen, just feel free to drop your question in chat box, or maybe you can ask your question directly by unmute your microphone. So please, ladies and gentlemen. So let's check the chat box. Okay, we have no question yet, but maybe I can confirm something maybe to Dr. Jayakodi. Is it okay, Dr. Jayakodi?
Of course, Ms. Davies.
Okay, Dr. Jayakodi, we have about 6 SGK, right? In your SGK or
Yeah, SCK.
what is it?
Specialized content.
SGK, yes.
SCK.
Okay, it's about six SGK, right?
Yes.
So, so do you think each teacher should like qualified with this all SGK, or maybe just some of maybe 4 or 5 is still okay? What do you think about that, Dr. Jayakodi?
Okay, thank you, Devi, for that question. So just like the MKT framework, our study looked at actual teaching of limit and derivative. And these SCK components were not like, it was not like we thought that this should be an SCK and we came up with a component. These were observed. These were observed through the teaching of these teachers. And the 6 components that we spotted, I think all 6 are important if you look at each of them, though there were like incompetencies of teachers in handling those SCKs. I'm sure each of these are assets would be assets if a teacher could have them, especially when teaching advanced concepts like limit and derivative. And like you asked, maybe some of them are more important, especially in advanced teaching, advanced level teaching, giving mathematical justifications to what they are saying. You know, when you explain something, to always say, why am I doing this? Why the next step is logically following from the current step, and things like that might be more important.
Okay, thank you so much, Dr. Jayakodi. It's so clear. All right, so let's check the chat box. Oh, okay, we have Desti Sila Silviana. Excuse me, my name is Sila. How can mathematical knowledge for teaching be effectively developed to address student misconceptions and support conceptual understanding of limits in calculus within a secondary or introductory territory classroom? So I think this question is addressed to Dr. Jayakodi. So please, Dr. Jayakodi.
Yes, now, thank you, Desti. I hope I'm pronouncing these names correct. I'm pronouncing your names.
Yes, it's correct. It's correct.
Sorry, thank you. So the what she is bringing out, the addressing student misconceptions. Surely that this is part of SCK. It's a teacher who needs to know the kind of misconceptions that, you know, widely known misconceptions that students have. If a teacher is aware of these misconceptions, he or she can mindfully bring them up in her instruction and clear them out. So even though we did not see this as a category or a component in the SCK of limit and derivative instruction, because it was not observed in the teachers, I would agree that this is something that any teacher should have at any level, that is a knowledge of widely known misconceptions that students have. Actually, for limit, there are misconceptions about the concept of limit that students have, and these arise from the colloquial, you know, the day-to-day use of the word limit. So if we are aware of this, this can be addressed. And the way to address this is by bringing awareness to teachers through teacher training and teacher development programs. Thank you.
All right, thank you so much, Dr. Jayakodi. Okay, next to Mrs. Darshi Waidaya Tilake. My name is Darshi. How can you manage the time and the way you connect the curriculum? I think this is addressed to Dr. Jayakodi also.
Yes,
What
thank you,
what
Darshi.
a very interesting question.
Yes, thank you, Darshi. A great question. This comes up all the time. Now, what we have to identify is that this SCK is not a separate knowledge that has to be taught alongside the curriculum. It is part of the curriculum. It is it should be embedded in the way you teach. So I think this could be a misunderstanding that this is what we discussed today, especially during my presentation, was a separate kind of knowledge that we have to give students in addition to teaching the concept. But in contrast, everything that we talked about is part of the teaching. So time management should be that, and curriculum is something that is lacking, because our teacher guides don't contain these things. So sure, that's something that we have to address and you know, include these as part of consciously include them as part of the curriculum. Hope I answered your question, Darshi.
Okay, thank you so much, Dr. Jayakodi. So let's go to the next question. Hello, I am Sujiva. You mentioned that advanced mathematical knowledge, such as abstract algebra, has become compulsory in teacher training institution. How has this impacted the effectiveness of mathematics teaching at the school level? So I think this question is addressed to Akta Siska.
All right, thank you, Mom Devi. Finally, I got the question. Thank you. I would like I would like to confirm whether Sujiva is a mom or sir. Can you
Yes,
help
yes.
me to confirm, Gaya?
She's a lady from Sri Lanka. She's a lecturer from
Oh,
university.
sorry.
She's a
My
lady.
voice. Okay. Is he or he?
She.
Okay, thank you.
Oh, so this
Okay,
is
okay. Thank you, Mom Sujiva, for your interesting question related to the impact to the effectiveness to the mathematical teaching in the school level. So this has also become our problem here, like how could we help our students in the university level, the mathematics pre-service teacher, to have a notice whether there is a great connection that they have to bring while they are coming to their future teaching. So our students have an opportunity to teaching internship, and there become such kind of opportunity for them to to train about how to teach mathematics in a better way. So if we are talking about how this effectiveness, but actually we do not have any particular result how the effectiveness, but then at least by showing the students that join in my classroom in the group theory or the ring theory, I'm trying to encourage my students to let their students know about the connection itself, such as the function, like the permutation in group theory, and then the solving linear equation as well, by showing their future students, I mean, like in the internship program, by explaining that kind of method in mathematics. We have like two sides equals we know the two side of the equation by using the equal sign, and then commonly the mathematics teacher taught the students by saying that we can move the number in the left side to the right side. But then I'm trying to tell my students in the abstract algebra classroom by saying that this is what actually mean the identity properties, and then the inverse properties is work here. But then we could not say our students in the school level by saying this is the inverse, this is the identity property. But then we can try to reduce the level of language that we used to explain by saying like, oh, this is the opposite of the addition operation, or we can try to tell them the opposite of multiplication, something like that. So hopefully start with the little things that the teacher do in the teacher preparation program. It could help them when they are facing the future teaching. So hopefully by the small thing that we can do as an educator in the university level, it could help to change the teacher mindset to bring the advanced mathematical knowledge itself into the school level. Hopefully, it could help Mams Jiva also to implement in the school level if you also have the similar circumstance. Thank you.
Okay, thank you so much, Mom Anita. Very clear explanation, I think. Okay, so next question, please. Maybe. Is there any question?
May I ask a small question from Associate Prof. Agneta? Agneta, may I ask a question?
Of course, Dr. Jayati, please.
Klein's double discontinuity is something that we have been interested to, and we have been looking at that, and we have been thinking about how advanced mathematical knowledge at the university level can be applied in the secondary level teaching. But Agnita, when I'm thinking about this discontinuity between secondary school and university level, something that came to my mind was there are discontinuities within the school curriculum itself, let alone university level. The content that we teach from, say middle school to secondary school, within that content, our teachers have, it seems like our teachers have not identified certain connections among concepts within the school curriculum itself, isn't it? Do you have to say something about that? I would like to know what you think about that, actually.
Okay, so you mean like the teacher itself also have the the limitation for the identify the syllabus itself in the school curriculum mathematics, yeah?
Yeah, it's
So
yeah.
yeah. So
Yeah.
the thing that we could, yes, please.
Yes, that's not seeing the connections, concepts taught within school curriculum itself. Have you noticed, like, for example, if you talked about the inverse. So inverse comes up in the context of functions, it comes up in the context of addition, multiplication, and even the to the power of -1, the symbol. There could be a disconnection between these things as well
Right.
within the school curriculum.
Yes, even also talking about the written symbol in the inverse itself, like some of the students also questioning about the inverse itself and the function inverse as a function and inverse as an element properties like that. And related to the what the awareness of the teacher itself, I would like to say that most of the teacher here as well, they also do not easily identify the connection itself until like we were trying to have such kind of community service and then share the findings from our result to let them know that it is kind of connection that what can teacher do. So another effort that our team do is we make a the book, the teaching book for the pre-service teacher that completing with the table, which is consists of the connection between the curriculum study in the school level and the material in group and ring theory. So this is kind of our effort to represent our research finding to let them the society know, particularly for the teacher in the school level, to have a synergy to collaborate together. Bring the advanced mathematical knowledge is not a totally the hard thing for the students itself, for the prospective teacher also in the university. They do not think about, oh, this is too hard for the pre-service teacher to learn about abstract algebra without knowing the relevance for my future teaching. Then yeah, it become hard if they have the perspective like that. I think that's my perception, Gaya. Maybe you have another perspective concerning this.
I agree. Yeah.
Yeah.
Thank you.
Okay, thank you so much, Dr. Jayakodi and Mom Agnita. We have another participants that will ask the question by Miss May Titania. But maybe we have to, I ask your permission to wait for maybe a minute because now we have to stop because now we have the pray calling right now, maybe about 1 or 2 minutes. Rasulullah Sallallahu Alaihi Wasallam. Okay, everyone, let's back to our Q&A session. So we have Miss Maydi Tania here. Okay, maybe Miss Vivi, can you please pin Miss Maydi Tania to our screen? Oh, karena nggak on cam, because she's not on cam, so okay, it's okay. Miss Maydi Tania, okay, time's your Miss.
Okay, thank you for the time, Miss Dewi. Yeah, I'm Bunga. I'm gonna ask a question for Miss Agnita. Yeah. Before, I'm sorry, I'm turning off my camera due to the lack of connectivity. Yeah, it's
It's okay,
a
Miss.
quick, yeah, okay. It's quick presentation, Bu Agnita. Actually, when we are talking about the ring theory, yeah, I just I have a question and also curious, how can we introduce the ideas from ring theory in simplified form, especially to secondary students without compromising the mathematical record? Thank you.
Okay, thank you so much. Wow, what an interesting question. I also want to know how to simplify ring theory in secondary school. Okay, it sounds so hard to be answered, but I think it's easy for Mom Agnita. Please, Mom Agnita.
All right, thank you, Mom Dewi, and thank you for such nice question from Miss Maiti Tania. That one of the big mission as a ring theory lecturer, how to bring this kind of course to be more sounds familiar for the even for the secondary students. So like well before we have already discussing with Gaia about how to make the teacher realize the connection, and then now how to bring this kind of to the secondary school be more understand and not to use the mathematical rigors, as we know, like in ring theory we talking about the from the basic concept of the ring properties. We learn about the binary operation, and then the inverse itself, the function, and then the identity element, and how to bring and how to explain to the junior high school or maybe senior high school. So such an example, while we are explaining the senior high school students related to the composition of function here. And then this is actually part of the connection in group theory in the permutation itself. But then we are talking about the ring theory. We will taking one of the famous concept such as the inverse itself. Like we do not let the students know about the inverse, like wow, we work in the a set and then such a particular operation, but then we could let them know, like saying, oh, I have the number, and then we try to bring into the real life by provide them with the short story, maybe. I mean the story problem for the students, and then by knowing the inverse itself, what is the definition of the inverse itself, and then giving the pictorial, and then the manipulative, it helped them to be more concrete. And also another thing, like the concept of homomorphism, make it the function being this the same, like making a juice, apple juice, pineapple juice, and then we mix all them together, like So what we can have, it tastes like the mixing of pineapples and the mixing fruit itself. So I think we could make like what's that, metaphor, or we could also use the real world connection, story problem, and then trying to tell them with the what's that, more easier way, without omitting the basic concept in mathematics. I mean, like, even though we are trying to expand into the easy ways, but then doesn't mean that we have to omitting the fundamental concept in mathematics itself. Hopefully it could help you what's that, picturing how to delivering this kind of abstract problem into secondary school problem. Okay.
All right, thank you so much, Ma'am Agnita. I think it's a clear explanation. Okay, we go to next participants who has already raised a hand. Okay, we have Camelia Alicia. Please, Miss Vivi, can you pin Miss Camelia in our screen? Okay. Okay, Miss Camelia, please.
Thank you, Ma'am Devi, for the opportunity. I wanna ask to Ma'am Gaya. How to develop mathematical knowledge for teaching us. I'm the prospective teacher in mathematical. Thank you.
Okay, Dr. Jayakodi, please.
Thank you, Camelia. I'm not very sure whether I got the question right. Did you ask how can we develop mathematical knowledge for teaching in prospective teachers? Was that your question?
Is that your question, Miss Camelia?
How we can develop? If I assume
How to develop?
yeah.
How to develop mathematical knowledge for teaching as I am the prospective teacher in mathematical.
Right. In the context of Sri Lanka, we do have a bit of a issue in that area because how our teacher recruitment happens here is, especially if I talk about the secondary school level, if you have a bachelor's degree in that subject, containing that subject, you can become a teacher. You can apply for a teaching position. We do not have teacher preparation courses. We don't have teacher certificates and so on. What we have are training and teacher development programs for in-service teachers. We don't have courses for pre-service teachers. We do have what are called national colleges of education, where teachers are trained and they go into teaching. So in terms of teacher national colleges of education, one way to develop mathematical knowledge for teaching would be to include this as a component in their courses, to include this in their curriculum. But many of the teachers, especially for advanced level classes, they come from through university doing a bachelor's degree, and then they apply for teaching, and they if they pass their interview and so on, they get that. They don't go through a teacher certification process. So there is no place in our system for us to give them that knowledge. It is only after they get into teaching through teacher training program, talk about this, edit them, and bring awareness about this. So it's a bit hard to do it here.
Okay, thank you so much, Dr. Jayakodi. All right, so I think we have the last question here because of time limitation. We have Selfie Nuraini. Miss, excuse me. My name is Selfie from University. I would like to ask, how can ethno-mathematical context, such as local cultural practices or traditional crafts, be effectively integrated into classroom activities to improve students' numeracy skill in meaningful and engaging ways? Thank you. So I think this question is addressed to Miss Iza Larasati. So Miss Iza.
Thank you for question, Selvi Nuraini. A try answer, Selvi Nurs. Ethnomathematics contexts such as local culture and traditional craft can be effectively activated into classroom activity by photographic mathematical concepts such as counting, measurement, or patterns with cultural activities familiar to students, using traditional units of measurement or playing traditional game in solving strategies and calculation such as counting tonggak seed. This approach not only extends numeracy skills meaningfully and contextually, but also foster a sense of love for culture and active involvement in the learning process.
Okay, thank you so much, Miss Iza. I think if I can conclude, it's because just such the games you mentioned before, they really close. They are really close to children. So I think so that's why ethnomathematics will works. Okay, so everyone, ladies and gentlemen, now we have finally come to the end of this lecture series, day one. But before I close the session, I would like to the all speakers. I would like to invite the all speakers to receive the certificates. So please, Miss Vivi. Hmm?
Not now, still in the same. Not now, still in the same.
Okay, I'm so sorry, everyone. Okay, the certificates are not ready yet. So yeah, I think that's the end of our event. That's all for today. Don't miss our next session in May 14th. So don't miss it. Thank you so much, everyone. Thank you so much for your participation, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Thank you so
warahmatullahi
much, Dr. Jayakodi.
Thank you
so
very much, Mom Dewi and
Thank you
Gaya
very
for
much,
your
Agnes.
Thank you
coming
very
and
much.
your
Yes.
share knowledge.
Thank you very
It's
much.
very insightful. We could have further collaboration, the similar topic that we have, and also the similar condition in the teacher training program in both Sri Lanka and Indonesia. This is a great opportunity for me, myself, and also I think
And
for
for me
all the
too.
participants here to know how the mathematical condition in different countries must be similar or totally different. Thank you very much, Gaya.
Thank
Very
you.
true.
Thank you so much.
Recording
See you,
stopped.
bye. Alhamdulillah.
Alhamdulillah.